Right. Mhm. Yes. Cool. All right, you're recording and you're on share screen. Well, greetings. Welcome to the fourth class. Let's start our time with prayer. Dear Heavenly Father, thank you for another class that again we can study the science of mathematics and again gain a deeper understanding of your knowledge and your beauty in the science of mathematics, that you have created this world with mathematical pattern and structure. Lord, may we appreciate that and use the knowledge that we gain from mathematics in sharing the gospel more logically, clearly to other people, and use the applications of mathematics in our church ministry. We pray and commit everything to your hand. I pray your blessing, especially upon all the dear students. May they all have the wonderful Thanksgiving, and also bless them as they work on their homeworks, assignments, tests. In Jesus' name we pray, amen. All right. Again, happy Thanksgiving to all of you. And maybe we can finish the class and go home. Be ready for Thanksgiving. All right. Today we are going to study about fractions, percentage, ratio, different measure units of measurement, and how to convert them. All right, that's there. Okay. Okay. As you can see in this picture, in this diagram, the fractions, I try to show them both graphically and mathematically. This is like the whole 1/1, half, 1/2, 1/3. You divide that to 3 equal parts, 1/4, 1/5, and so on, and continue to all the way to I think that's 1/16. No, 1/10. I'm sorry. Okay. In roll, slides, covers, again, the whole idea, this is half. When we talk about 1/2, we're talking about, half of something, or this would be 2/3. This would be 1/2, and it's been divided over 6 parts, so it's 2/6 or 1/3. Okay. That's how it works. Did you follow that? What I did here? So, just 2 divided by 6. There are 6 parts, so it's 2/6 or 1/3. Like this one is, if we are looking at the dark orange area, 1, 2, 3, 4, it would be 4/5. It's been divided to 5 parts, and we are talking about the dark orange, which there are only 4 of them. Okay. I'm sorry, you don't see my mouse. You know what I'm talking about. All right. Good. We're going to talk about percent and percentage. It's very easy. Basically, when we talk about percent, it's simply a ratio of some number to 100. That's the reason I'm saying it's very easy. In order to expressing a number as a part of a 100, you divide the numerator by the denominator, and you multiply it by 100. For example, if it's 2/4, 2/4 would become 1/2, and you multiply it by 100, becomes 50. So 50%. You add the percentage sign. So if you have a fraction to decimal to percentage, you have a decimal number, you want to make it into a percentage, you move the decimal point 2 places to the right and attach the percentage sign. And if you have percentage, you want to convert it to decimal, you move the decimal point 2 places to the left and remove the percentage sign. Let's, again, these things are much better understood if you look at some specific example. Let's look at page 444, 444. All right, samples 1 and 2. Look at example 1, page 444. It says express 5/8 as a percent. So you divide the numerator by the denominator. 5 divided by 8, the answer is 0.625. All right. Then you multiply it by 100. 0.625 times 100. You see, here's a decimal point. When you have a decimal and you want to change it to percentage, you move that decimal point toward the right. So it's become two places, 62.5, and then you just put the percent sign. So 5/8 is the same as 62.5% of whatever, it's not mentioned. Now, if we have looked at page 445, example number 2, it says express 0.47 as a percent. So actually what you're doing, you're multiplying that number by 100, and when you do that, you move the decimal point 2 places toward it moves 2 places toward right, so it becomes 47%. Okay. All right. Let's look at example number 3 at the bottom of that page. Here it has given us a percentage, 19%, so express that as a decimal. 19% is the same as 19/100. And 19/100, it just when you have it, you just move the decimal point 2 places to the left. So it becomes 0.19, and then you cross the percentage sign. So 19% of something is the same as 0.19 of whatever, the same thing. All right. You do the same thing if you have 180%. You move the decimal from right to the left 2 places. So 180% is same as 1.80. You're actually dividing by 100. That's what you're doing. Percentage comes, and the knowledge of percentage comes very handy in figuring out sale tax and income tax, these things. Sale tax amount is tax rate times the item's cost. For example, let's look at page 446. In fact, it has the formula over there. The A is equal P times B. So sale tax amount is equal to the tax rate times the item cost. It says, example 4, suppose that the local sales tax rate is 70.5% and you purchase a bicycle for $894. How much tax is paid? So you take the price of the bicycle, $894, and you multiply it by tax rate, which is 7.5 again, and 7.5, you convert that to decimal. It's the same as because we are moving from percent to decimal, you move the decimal point 2 places to the left. So it becomes 0.075, and you do the multiplication, and the answer is $67.05. Okay. All right. So that's the tax you pay, or you have to pay. What is the bicycle total cost? Then you take the price of the bicycle without the tax, you add the tax to it. So the price, the total cost is $961.05. Right? Okay. And percent and sale price, let's look at example 5 on page 447. Okay, this is, okay, example 5, it starts from the bottom of page 446. It says a computer with an original price of $1460 is on sale at 15% off. So we want to know, when they say you get 15% off, how much actual money they are talking about. What's the discount amount? So you take the 15%, you multiply it by 1460, the price. 15%, I convert that to decimal. So I'm going from percentage to decimal. I move the decimal point 2 places to the left. It becomes 0.50. Multiply by 1460, you get the answer 219. So you save $219. That's the discount that they give you. What's the computer sales price? Okay, what's the amount that you actually have to pay at the end? You take the original price, subtract it from the this discount, you get $12.41. So you end up, you have to pay $12.41. Okay. All right. Price increase. Okay. For example, if I have a couch, the couch sale price, I want to buy a couch sale price is $400, is going back up to $450 on Friday. So actually, they're not talking about Black Friday. So how much will I save if I buy it before Friday? What's the percentage saving will that be? Okay. So I want to know, if I buy it before Friday, how much I will save, and what percentage saving that will be. So here, you if it's the current value is $40. If the starting value is $40, it's going to go up to $450. You subtract the 2, you get $50. So you are going to save $50. Now, what percentage do you save? You take that increase in the price divided by the original price, by 400. We get 0.125. So if I want to convert that to a percentage, I have to multiply that by 100. Okay, so I get, well, if I do that, then I get 12.5. I move the decimal to the right, to the 2 points. So I will save 12.5%. All right. Is that clear so far? No. Something that you will see in many places. In fact, this is a good thing to know regarding church ministry, in a study of your congregation, your people. It's called percentage pie chart. And, they give you, in a church, you figure out, for example, there are under 21, the people who are under 21 age, there are 15% here. People between 22 and 30, there are 20%. Between 31 to 40, you have 32. So That's the largest age population that you have. Between 41 to 50, you have 28, and the least is between 51 and up, 5%. In this way, that helps to understand the nature of your church. I realize the importance of the spiritual issue, but the people at different ages also have different kind of needs. I do understand the basic needs, but it helps to know it helps very much if I know that 15% of my congregation are under 21, so I need to have lessons, ministries that is focused on them. And that helps you to also to allocate your money, the budget, how much money you want for this group, that group. All right. One of the things that you will see quite often in this country and other countries, sales and percent off. Oops. Okay, let's go to table 8.1, example 6, page 448. That table 8.1, it's of course these things have changed whenever they make that table. It's supposed to give you information for computing income tax. So if your income, depending how much is your income, depending on whether you're filing your income tax single, married filing separately, married filing jointly, or head of a household, there are different rates. Let's take the first column, the single one. Up to $8,025 tax rate is 10%. From 8,000 to almost 32,000, the tax rate is 15%, and it goes up, so on. And also it gives you the standard deduction and exemption per person. Okay, now to understand that better, let's look at example 6. It says calculate the income tax owed by a single woman, no dependents, whose gross income adjustment and deduction and credits are given in the margin, in that margin of the page, that green box. Use the 2008 marginal tax rate in table 8.1. Okay, this is from 2008. That's 15 years ago. All right. So first, we want to find how much this person has to pay taxes. So first, we need to figure out the adjusted gross income. The adjusted gross income is you take the income of the person, you subtract the adjustment. Her income is 60. This is how much she made in the previous year, 62,000. Okay. Adjustment 4,000. So see what happens. Okay, yeah, because adjustment, that green table says 4,000 paid to a tax deferred IRA. You can subtract that from your taxes. So that's where that 4,000 comes from. Her gross income was 62. So you get 58,000. All right. You follow me?
Yes.
Okay. Now we want to find out the taxable income. The taxable income is adjusted gross income minus all the exemptions and deductions. The adjusted gross income we figured out is 58,000. All right. The exemptions and deductions, we know from the table 8.1, the exemption per person at the last row is 3,500 for a single person filing, unmarried or divorced, legally separated, filing as a single person. Okay, now we have to figure out the deductions. Now you see on that green table, it tells us that she paid, you can subtract these from your income. $7,500, she paid mortgage interest, $2,200 property tax, $2,400 charitable contribution, $1,500 medical expenses, but that's cross because you can only deduct amount in excess of 7.5% of the adjusted gross income. These are you don't need to. These are just IRS rules, but that's basically it has to be more than 70.5%. You can use as deduction because this is 1,500 is not more than 7.5% of the gross of the adjusted gross income. She can use that. So we add those 7,500, 2,200, 2,400, we get 12,100. That's her total deductions, total deductible. Okay. So now we take that 12,100 and put that for deduction in the formula for the taxable income. Taxable income, remember, was adjusted gross income minus exemption and deduction. We figure out the adjusted gross income 58,000, the exemption 3,500, and we figured out the deductions 12,100. We add those and subtract it from 5,800, we get 42,400. That's her taxable income. In other words, that's the amount that actually IRS looks at to, and based upon that, they get taxes. So she earns 62,000, but actually she has to pay taxes of 42,000. Okay. Now, in order to figure that out, you have to use that table 8.1. And you see the way it works is this. Look at the first column. It says a tax rate. The second column, it tells you when you're single, up to 8,000 is 10%. From 8,000 to 32,000 is 15%, and so on. So it has put that in that table on the side of page 449. Okay, so look at that. That's 1, 2, 3. The third paragraph, the tax computation. Okay, so you see it says put it on as it in a green in a blue ink. It says up to $8,025, which she has to pay 10% taxes. See that? Multiplied by, so 10% is 0.10. Okay, plus, but she has more. There are more taxable income from 32,550 to where are we? Okay, you see on the it says on the and in the table 8.1, or it doesn't matter that or that yellow table on the side. From 8026 up to 3250, 550, you pay 15%. Okay, you following me? So you subtract 550 minus 8,025. Okay, you following me? Whatever the amount, you have to pay 15% tax on that portion of the taxable income. Okay, but it's not finished because she made more than that. She has more taxable income. She has up to 42,400. So you take 42,400 minus 32,550, which was the top limit for the previous tax rate. for that amount, you have to pay 25%. Okay, are you guys following? So you see, you know what I'm doing, or the book is doing. So you do all those calculations. The taxable computation is on finally is $6,943.75. So you take that, and then the income tax. Now, finally, the IRS also gives the person $500 tax credit. You subtract, you have that also in that green table. You subtract that. That's the final tax. She has to pay $6,443.75. To follow everything, is everything clear? So the key is to remember they go 10%, 15%, 25%, depending upon the income. She has 42,000, so they go up to 8,000, 10%, up to 32,000, 15%, from 32 to 42,000, 25%, she has to pay taxes. They do all the computation, and they also subtract the standard deduction, the tax credit, tax credit $500, and then you get the income tax sold. Right? Okay. Now, percent and change. Lots of times we are interested to know when the amount is increasing or decreasing, and we want to find a fraction for the percent increase or for the percent decrease. Find the percent increase or the percent decrease by expressing the fraction in step 1 as a percentage. So let's look at example 7 and 8 on page 450 and 451. Example 7, that is world population based upon the data in 2000, year 2000. It says, for example, it says find the percent increase in the world population from 2000 to 2150 using the high projection data. They have two kind of projection. The high, actually 3 kinds: high, medium, and low, depending upon what happens to the population. If we want to use the high projection, which is that blue curve, in the year 2000, the population was 6 billion. Okay. In the year 2050, or 2150. Oh, wow. So we're going to the next century. 2150, they project the high population would be 30 billion. So they take 30 billion minus the original one, 6 billion, you get 24, and you divide that by the original population, the 6 billion, you get 4%, or you get 4, you multiply by 100, you get 400%. So the high projection is this, that by the year 2150, the population of the world is going to increase 400%. The low percentage, if you go by the low projection, which is that green curve, in the year 2000, again, the population is 6 billion. They predict in the year 2150, the population would be almost 4 billion. So you actually have decrease. So you take the original minus the projected future population, becomes 2, divided by original 6, you get 1/3, or you can write it as an improper fraction, or actually, in my opinion, the easier thing is right there, when you have 1/3, multiply that by 100. You get 100/3, and then divide 100 over 3 and express that as an improper fraction, it becomes 33 of 33 1/3%. So that's the population decrease. Okay, the percentage. You guys following? You know how to do that multiplication. You divide 100 by 3, and remember it goes 33 times. The remainder becomes the numerator. The divisor becomes the denominator, and that quotient becomes that prime whole number on the side. All right. Okay. 451. Okay. Example. Okay. Let's look at example 8. Also, it talks about the jacket regularly sells for $135. The sale price is $60.75. So the price is going from 135 to 60.75. What's the percentage decrease? What's the rate of this sale price? So you have the original price 135 minus the future price 60.75, divide by original. Okay, you get 74.25 divided by 135, or 0.55 multiplied by 100, you get 55%. So they are giving you almost half price discount. Right? In banks, you have different kind of banks, financial institution. You have simple interest or compound interest rate. The simple interest rate is principal times rate times time. Let's look at example 1 and 2 on page 455 and 456. Okay, the formula is I is equal to P, the principal, times the rate times the time. For example, if you put $2,000 in a saving account at the bank, and they tell you, well, actually the rates are much lower these days, but they say they give you 6% interest. You add that to your money, and you keep that money in the bank for 1 year. So the principal value P is 200. The interest rate is 6%, so it becomes the 6%. I want to write it as decimal, so I move the decimal point 2 places to the left. It becomes 0.06, and the T time is 1 year. So you multiply all these together is 120. So at the end of the year, if you don't touch that 2,000, your money will become 2,000 plus 120. 2120. Or look at example number 2. A student took out a simple interest loan of $1,800 for 2 years at a rate of 8% to purchase a used car. Well, that's impossible these days, but in order to figure out interest on the loan, again, the same formula. The principal is 800, the rate is 8%, so I move the decimal 2 places to the left, is 0.08, the time is 2. So yeah, this student, he or she has to pay $288 extra at the end for the loan that he got. All right. Now we also have future value and a kind of a more compound interest on page 456. You know, you have the principal plus the interest, but the future value A of a P dollar at a simple interest rate R for a T years is given by this formula. A is equal to P times parentheses 1 plus RT. So let's look at example 3 on page 456. The bottom of the page 456. Calculating future value. A loan of $1,060 has been made at 6.5% for 3 months. Find a loan future. So again, we use this formula. A is equal P parentheses 1 plus RT. The principal loan was 1060. 1 is 1, then the rate is 0.65%. I move the decimal 2 times to the left, it becomes 0.065, and the year is, where's the year? Oh, 3 months. Find the loan futures value. Okay, we want to use the year. That time should be in the year. Now, 3 months is, how many months are in a year? 12 months. So it's 3 of 12, or 3 over 12, or 3, I can subtract it, 3, the 12 divided by 3 is 4, so it becomes 1 over 4. You follow me? So, or it's 1 over 4, it's the same as 0.25. That's where that 0.25 comes from. And it shows that in example. Because 3 months is 3 over 12 of a year, 3 over 12 is 1/4 of 0.25. And when you do the calculation, the rounded number is 1077.23. So the future value of that loan. So the person wants to clear up that loan, has to pay that extra amount. All right. Okay. Let's look at example 5 on page 457. Do you plan to save $2,000 for a trip to Europe in 2 years? You want to go to Europe, you want to save money for it, and you want to do that in 2 years. So you put the money in a certificate of deposit or CD, and they tell you the rate is 4%. They give you interest. So again, you take the formula here. Actually, here, you know the future value. You know this is how much you want to save. So you want to actually find out how much I need to put in the bank so that I can have $2,000 at the end of 2 years. So you have the A, you have the rate, you have the time, you don't know the P. So this time we are solving that equation for P. So it's 2,000, and then you have P times 1 plus, again, it tells you the rate is 4% or 0.4, and you do the calculation in that parentheses, in that brackets, and you get 2,000 is equal to 1.08 P. You divide both sides by 1.08, so the P is 1851. Okay, so if you want to have $2,000 at the end of 2 years for your trip, you need to put initial of 1851 in the bank, in that CD. All right. Now, compound interest rate, installment loans, minimum payment traps, and mortgage loan. These are very important things to know for your own life. On page 460 through 490 talks about all these things that compound. That formula, for calculating the amount in an account for compound interest rate once a year. It's at the bottom of page 8.3, and we give you this formula. So you have A P1 plus R. Now, the whole parenthesis is to power of T. Now, calculating the amount in account for a compound interest paid N times a year, okay? Then is P1 R over N to power of NT. All right. This is for you, for your own personal reading. But I always encourage people to learn these things, avoid traps, especially here in this country. There are so many traps that they try to get you into by these credit cards or car loans, and you got to really figure out what you're getting yourself into. Now, measurements. Let's go to measurements, units, and conversions. This is a good, kind of easy thing to remember. King Henry died drinking chocolate milk. The K for king for kilometer, H for hectometer, D for decimeter. 1 kilometer is 1,000 meter at the bottom row. Hector is 100, and deci, if come from deca, means 10, is 10. Okay, so if you go when you're going toward the king, you're increasing, yet the number gets bigger. This way you go bigger, that way it goes smaller. D for decimeter is 0.1, centimeter is 0.01, and millimeter is 0.01. You come smaller as you go here. All right, keep that in mind. And to try to memorize that sentence, King Henry died drinking chocolate milk. Now, to convert a measurement to a different unit multiplied by a unit fraction, the given unit of measurement should appear in the denominator. The unit of measurement that needs to be introduced should appear in the numerator. Let me, again, these things, if you look at an example, makes it more easier. Let's look at these. For example, let's go to page 503. Okay, it says convert 40 inches to feet. And it says you have to also remember, we will give you that table, that green table on the page 502, okay? If we have 40 inches, we want to convert that to feet. So let me, let's see that. So we have 40, what's the unit? Inches, okay? We want to convert that to feet. And from that table, we know 12 inches is equal to 1 foot. Now, remember, just a simple thing to remember. Whenever you want to convert something, you want to convert that to feet. This should go into the denominator. This should go here. Oh, no, I'm sorry. This should go inch. This should go here. and this should go into the denominator, inch, so that these two can be canceled. Okay, so 1 foot is equal to 12 inches. So I multiply that by 1/12. So 40 inches times 1/12 becomes 40/12. I divide both by 4. This becomes 10. This becomes 3. So it's 10/3 feet. Or you can do the improper fractions. Yeah, you can do the improper fractions. It's 3/1/3. Same as, when you divide 10 by 3. So it becomes this 3 over 1/3. So this becomes the denominator. All right. So the key is this: you want to convert from inches to feet. You find a relationship between 1 foot to inch. This has to go in the denominator, so it will cancel out with this. All that. Let's look at example B. We have 13,200 feet. Says convert that to miles. $13,200 feet. So I have 13,200 feet. I want to convert that, get it in miles. Okay. Now you look at that table, the relationship between feet and miles tells you that 5,280 feet is 1 mile. All right. So if I want to get this feet multiplied by a fraction, the feet has to go here. Yeah. So it tells me 5280 feet. Okay, yeah. 5280 feet is equal to 1 mile. Yeah. So you multiply that, this feet cancels with that. So you get that number, 13,200 divided by 52.8. And the unit is miles. Okay. So you do the division, and you end up with 2.5 miles, 2.5. All right. So the key is this: the unit that you want, it gives you a number in some specific unit, tells you to convert it to another unit. You have to multiply by a fraction. The denominator of that fraction must have the value of this unit. So they two can cancel out. And the numerator, the value of the unit that you want to get to. Okay, that's the key things. Let's go to page 506. Was that clear? 506. Okay. It says example 2. It tells you convert 504.7 meter to kilometer. Okay. 504.7. 704.7 meter. We want to convert that to what? Kilometer. Okay. We want it to kilometer. So I have to multiply this by a fraction. Now, what before I put the number, but whatever the meter part goes here. Because I want these two to cancel out. The kilometer part goes here. All right. So what's the relationship between kilometer and a meter? 1 kilometer is how many meters? 1,000. So this goes with that goes with that. So the answer is 5.4.7 divided by 1,000 kilometer. And it's very easy always to do the 1,000 or 100. You just move the decimal point here. 1, 2, 3. So you get 0.5047 kilometers. Almost half a kilometer. All right. So it says convert 27 meters to centimeters. Now let's do that also. 27 meter to centimeter. 27 meters. We want to get to centimeter. Okay, so I have to multiply this by a fraction. The meter part should go where? Under. And the centimeter goes up there. Now, what's the relationship between 1 meter and a centimeter? 1 meter is how many centimeters? 100. So these two cancel. 27 times 100 is 27,100 centimeters. All right. Okay. Let's do number C also. It says convert 704 millimeter to hectometer. 704 millimeter. Okay, we want to convert that to hectometer. Okay, so I have to multiply that by a fraction, and the millimeter goes here. So, but that's kind of tricky because we are moving, again, remember that sentence, King Henry died drinking chocolate milk. So, if you look at that, look at page 5 or 6, the answer to example 2, part C, you see you're moving from millimeter, you're going to hectometer. So millimeter to centimeter, then decimeter, meter, decameter, and hectometer. So you are moving 5 places. So all you have to do is actually you move the decimal point to the left by 5 position, or you're actually dividing. Well, no, let's not do that. That become more confusing. Just remember that KM, HM, DAM, M, DM, CM, and MM, King Henry died drinking chocolate milk, and the middle one is just a unit. So you're moving from millimeter 5 times toward the left. So you move the decimal point for 704. The decimal point is right there behind after 4. So you move it 5 times. it becomes 0.00704. Okay. In these things that there is not a one direct relationship, it's better to use that sentence. Okay, you follow me?
Yeah.
All right. Let's go to page 508. It says convert 8 inches to centimeter. Now, it has given us the table 9.3. It says 1 inch is equal to 2.54 centimeter. So again, I have 8 inches. I have to multiply it by a fraction. The inch part goes to the denominator. 1 inch is, and the numerator gets 2.54 centimeter. So you just multiply, the inches cancel out. 8 times 2.54 becomes 20.30. All right. You just, that table will be given to you. Let's do 509 example 4. You know, the speed limit on many highways in the United States is 55 miles per hour. How many kilometers per hour is this? So we want to convert from miles per hour to kilometer per hour. I write the fraction, 55 miles over 1 hour, okay? Now, I need to multiply that by a fraction that, again, the miles, I want to get rid of the miles must cancel out. The miles must cancel out, so that goes into the denominator. 1 mile, again, we have that from table 9.3, is equal to 1.6 kilometer. So I put that in the numerator, I do the multiplication, the answer is 88 kilometer per hour. Is that clear? So you need to know the relationship, and whatever you want to convert from this unit to that unit, you have to multiply by a fraction. And if you're then in the denominator of the fraction should be that unit that you want to, original unit, you want to get rid of. And when you don't have a one-to-one relationship like table 9.3, then use that sentence. King Henry died drinking chocolate. All right. Another thing, we come to geometry and calculation of areas. Some of these you got to remember, you know, how to do. The triangle is base times half the height. Square is double the one side. Rectangle is basically the same thing, but because the side is different, so you have, you know, a square is actually, I'm multiplying a by a, I get a square. But here I'm getting w by h. W by h, I get the area of the trapezoid, add this side plus this side times the height divided by 2. Some of these you have to memorize. If you have a circle, R is, you know, same things. R 1.5 pi r squared. The divided by 2. Pi times square root of the square of the radius gives you the area of the whole circle. Then you have to divide it by 2. You know, a same things. You know, these are just some examples with numbers. You may have question. No. You may have complex circles. So if you have that, what should you do? Divide it into areas. For example, if I have that, okay, I know this side is 3 inches, 3 centimeters. This side is 5 centimeters. So I can measure that area. Area is what? How much? 15. Okay. And so I get that. Then I want to calculate that top part. Okay, well, here is 3 centimeter, 3 and 3. So what's this line? 9. And I need to know, this area. So how do I figure that out? I know this is 5. This is 7. So this tells me it's 2. And yeah. So that's 1. So you get 9 times 3. Oh, no, I'm sorry. I'm looking at the wrong, ranking. I want this bolded in. So this area is 3. This is 3, and this is 3. Now this is this is 5, and this is 5. This is 6. Okay, I mean this is 7. So this is 2. So it's 2 times 9. I was looking at the wrong. 18 centimeter square. Volumes, again, basically, volume is you take the area of the base and multiply by the height. If this is 5 centimeter, and one side 5, this is 6. 5 times 6 gives you 30, and then you just stack these things up on one another times 3, you get the volume. Here, if this is 6, this is 5, 6 times 5, 30, and then you go 4 centimeter high, you get the volume. These are, again, some formula for volumes for different shape. The cube, again, notice, you find the area of the base is a square, a times a, and then you have to go a times I, so it becomes a cubed. The rectangular prism, find the area, a times b times I. How many times you have to put this together? Cylinder, find the area of the base. The base is what shape? Circle. So it's pi times the d to power of 2 times h, the diameter to power of pi is pi times d2 multiply h times okay, I know what they did here. Okay, well, you can go by that, but actually what they did is what is a formula for finding the area of the square circle? Pi times no r squared. All right. So the reason they put d over 2 because they wanted to divide that. I can, instead of radius, I can put the diameter, which is 2r, but then I have to divide it by 2. Okay, so that's why they get. So if they want to use because these, okay, let's put it this way. The diameter is equal to 2r. All right. So if you have the area of the circle is pi r squared, if I want to use d, I have to say pi is this is the same as d over 2 equal to r. Okay, so I get d over 2 to the power of 2, which is the same as pi times e squared over 4. That's where that part comes from. Okay, you see that? So basically, they're using diameter instead of radius. That's fine. But then they multiply by height. So you see, you just have area of one circle, and then you go all the way. You get the volume. All right. Now changing units. If we go to page 521. Again, that's like what we did before. Let's look at example 2. You know, it says an aquarium holds 0.25 cubic meter of water. What's the weight of that? So on the table, it tells us 1 cubic meter is equal to 1 kiloliter or 1,000 kilogram. Okay, so you want to convert. You want to find out the weight. You want to go from volume to weight. We know 1 cubic meter is 1,000 kilogram. If I have 0.25 meter, so I multiply by a fraction that the denominator has that cubic meter. Okay, 1 cubic meter is equal to 1,000 kilogram. So those cubic meter will cancel out, and you multiply 25 by 1,000, you get 250 kilogram. Do you see how that's working? All right. If you look at page 522, the example 3 from the bottom of page 521, it says convert 160 pounds to kilogram. So we want to go from pound to kilogram. So you have 160 pounds. You look at that second line at the top of page 522. You multiply by a fraction. You want to convert to kilograms, so you put the pound in the denominator of the fraction. And 1 pound is 0.45 kilogram. That's given to us by table 9.10. All right, on the previous page. So you multiply it and you get 72 kilograms. Right? Okay, let's move on. Then the last thing we talked about, temperature, are basically 2 units, centigrade and Fahrenheit. To convert Celsius value to Fahrenheit, we use the formula, and this is the formula. Yeah, Fahrenheit is equal 9/5 times centigrade plus 32 times centigrade. Let's look at example 4 on page 523. You know that these are the 2 formula, or you can use the formula that we have up here. From Fahrenheit to centigrade, or from centigrade or Celsius to Fahrenheit. These are the 2 formula. It says in example 4, you know, if the thermometer reads 37 centigrade, we want to find what's the value in Fahrenheit. Just take that formula and put the value for C and do the multiplication and addition, so you get 98.6 Fahrenheit. 98.6 Fahrenheit is 37 centigrade or Celsius. All right. Converting from Fahrenheit to Celsius, and again, the formula is right there, and you had the book also give it to you. All right. Like example 5, page 524. If you have 77 Fahrenheit, we want to find how much Celsius. So you put that in the formula and do the multiplication and addition. All right. Oh, basically that's it, guys. Any question you have for midterms, anything? Just from if you are doing your homework, your assignments, you understand the principle, go over the PowerPoint, go over the examples, I think you should do good. All right? Anything, any question?
So it's 2 hours long, right?
I believe so. It's 2 hours. I can even increase that if that's not enough.
Oh, no, it's okay.
Okay.
It's going to learn how many time, because I told you before that I'm like slow. Exam, sometimes I'm very slow.
Oh, okay.
But yeah,
I'll increase the time. Don't worry. I increase the time.
No, okay. How many questions are there?
Huh?
How many questions do you know?
I don't remember right now off my head.
Oh, yeah.
I think we can find out if you want. Let's stop sharing. Okay. Okay. There are how many questions? Doesn't tell me. Oh, to be honest with you, it doesn't tell me. Okay, let me. I gave you 2 hours, but I will increase the time. All right. Okay. Anything else?
So the questions of the midterm are basically, they come from what we already learned?
Yes.
Oh, yeah.
Yes.
Like so far?
Yes.
From week 1.
From session 1 all the way through end of today.
Okay.
All right. Okay. So God bless you. I hope you do great. I'm sure you will do great. And have a blessed Thanksgiving.
You as well.
All right.